Good evening, everyone.
Oh, there's.
Good evening, everyone. I hope everybody can hear me. If you can't hear me, maybe write something in the chat. All right, thank you. So welcome to our very first webinar for our data visualization Zürich meetup. So for those who don't know me, I am Luc Guillemot. I am a front-end engineer at Interactive Things, and I co-organized this meetup with Benjamin Wiederkehr, who is also with us tonight, and who will be moderating your questions. Yes, so for those who who join for the first time our meetup, we are like a group of people like interested in data visualization, and we usually meet every month in the studio of Interactive Things in Zurich. But yeah, for obvious reasons, it cannot happen right now. So we decided to hold a webinar instead. Yeah, so it won't be exactly as usual. We can't have the chat and the drinks afterwards, but I think it's going to be like a very rich anyway. And I'm very, very happy we can have the event anyway. Before moving on to the presentation itself with Ilya, just a few organization notes. So we will have a presentation for about 40 minutes. And of course, we welcome questions if you have. And to do this, there is a tab below the video feed that you should see, ask a question. And if you click on it, you have a pop-up, and you can write questions. You can do it anytime, and we will try to maybe prioritize or to see what we can answer at the end of the talk. And you can also upvote questions that others have submitted. Yes, I think that's all for the organization notes. So we can move on to our agenda for today. We have the great pleasure to have with us Ilya Boyandin, who will talk about Flowmaps. So Ilya is a data visualization engineer who works at Teralytics and is the creator of Flowmap.blue. Yeah, so I think it's a very interesting topic that we will dive in a very specific type of data visualization that has famous challenges. And I think Ilya created a tool that is very creative to solve these issues. So we're very happy to have you, Ilya. And I will leave the stage for you now. We can hear you.
I think I pressed the wrong button. No. Yes. So I'm trying to share my screen.
All right.
Okay.
So we can now see your screen, your slides full screen.
Thanks, Luke. I'm pretty excited to speak at this meetup. So yes, I will be speaking about Flowmaps. And I want to start with a short story. So this was an eruption, volcano eruption in Iceland, about precisely 10 years ago. And Yes, because of this eruption, the air traffic in Europe was like many airplanes were cancelled, and I was supposed to go to a conference in Portugal. That was my very first real conference where I had to present. And when I arrived to the airport, they said that the plane was cancelled. And so I thought about it. And actually, my wife helped me to make a decision. She said, if it's important to you, you should go. And so I decided to go anyways. So it became a train trip to Portugal instead of the plane trip. And there were 7 changes on this trip. It took 30 hours. But finally, I arrived in Guimarães. And the conference organizers were very happy that at least some of the speakers showed up, because half of the participants didn't. And at this conference, I gave a talk about flow maps. And it was precisely 10 years ago. And it's a bit funny. I'll even reuse some of the slides today from the 10-year-old presentation. But there will be some new stuff too. And at this conference, I also presented the tool I developed as part of my work on my thesis at the University of Fribourg. And I worked on flow maps. And I developed this tool, Flowmap, for drawing flow maps. The tool wasn't particularly easy to use, and it also didn't perform very well. That's why it didn't become very successful, although a few people tried to use it. But yeah, somehow, even after finishing my studies, my thesis, I still felt the need to work on this, because I thought that the problem wasn't solved and I could find a better solution. And I felt that there was a need for such a tool, because some people tried to use what I developed, even if it wasn't perfect. And so I looked for opportunities to work on some projects in this direction, representing movement of people or goods. Some of them were when I was at Interactive Things. And actually now I work at the company Teralytics, where we developed tools for analyzing movement of people in cities and countries. And the flow map visualization is an integral part of the tools we develop. So let's try to define first what a flow map is. It's a little bit blurry, but we can try to give it a name, to explain what it usually is. So it's a representation of entities moving between locations. Usually it's geographic, or at least spatial. So there is a space component to it. I've seen flow maps showing the connections and the information transfer within a brain. Usually it's about entities moving between specific origin and destinations, but not always. I will get back to it in a second. Usually the amount flowing is also important, and there are different ways of showing it. We can use different visual variables to encode this information. The direction is also often important, but not always. And also different visual variables can be used to represent the encoding, the direction. So there are two basic kinds of, at least two kinds of flow maps. Those which are focused on the amount flowing through specific route segments, and those which show the amount flowing between specific origins and destinations. They are similar, but not quite the same. So for the first ones, the origins and destinations are actually not important, maybe not even known. And for the origin destination flow maps, the routes are not important and are not represented, usually. The second kind is more challenging, because there is a more there is line overlap, right? We are drawing lots of lines, and they have an overlap. And the segment flow maps are not that challenging to draw because there are no overlapping lines. They can also be represented as ODs, as origin destination. At least the data behind them can be represented as OD data if we use the sides of the segments as the locations, origins, and destinations. So, like the origin destination flow maps can be considered a more general case and also more challenging. So I'll be speaking about them in the rest of the presentation. And so OD data, origin destination data, can be represented in a simple table with 3 columns: origin, destination, and the count, the number of trips or the amount moved, whatever the data is about. And it doesn't have to look like this map with arrows. It can look very differently. Like this one is animated, and the number of particles moving shows the flow magnitudes. But here there is a clear origin and destination. This is similar to the previous one, but I wouldn't consider it a flow map, actually. It's a vector field representation. This is a wind map showing the speed and direction of the wind around the globe. And here, actually, there are no origins and destinations. There is a vector in every point with a certain direction and speed. It's a different kind of data, although the representation is somewhat similar. So a little bit of history. This is the first known flow map showing passenger conveyance in Ireland, made by Henry Harness in 1837. Charles Leminard, not much later, started making his flow maps, and he really popularized the techniques. He made a lot of them, like, for instance, this one showing global migration. I can recommend this book, which is a collection of the works by Charles Leminard, many of them of which are flow maps, including the famous Napoleon's Russian campaign, which is on the cover here. Sorry. So Walter Tobler, an American geographer, has started experimenting with generating flow maps on computer, and he published quite many papers. He developed a tool called Flowmapper for flow map generation, and he in his papers he discussed many issues around representing flow maps, like here how to represent bidirectional flows, for instance. He also discusses the issues of flow maps. The most pressing one is the visual clutter. If we draw many lines which are overlapping, it becomes difficult to read them, the flow maps. Another problem of flow maps is that flows which are short are more difficult to see, although often precisely the shorter flows have higher magnitudes because people tend to go to closer locations. Like here you can see, like, for instance, this flow is rather thick, but it's short. That's why it's difficult to see. And here there is one which is behind another one, and it's very difficult to see. And Tobler discussed a few solutions, like how to reduce the number of flows we have to display, right? The most obvious solution is to remove the smallest ones. They are not very important. But how do you find where to put the threshold? And here he suggested a way to calculate a score and metric, which would tell us where to put the threshold so that we can keep the most of the trips while removing the most of the arrows, right? And there is an optimum in this metric function, it's around, in this case, it's around 9,000. That's where we can put the threshold, and then we would see fewer flows, although we would see the most important flows. And the total number of trips shown will be high. And here, if we set the threshold too high, like here 50,000, we remove too many flows. We don't see a good overall picture anymore. Another technique he discussed in his papers was segmenting. Like the idea is that we split longer flows into a sequence of shorter flows between the adjacent locations, right? This way we won't have any, and we combine them, right? This way we won't have any overlap actually. And we see a good overview, but we actually lose some information because we don't see anymore what are the origins and destinations. Like we don't know where these flows within this arrow are actually coming from. It's a sum of all the arrows arriving here, but we don't know their actual origin. So we lose the origin destination nature of the data. And this technique is very similar to edge bundling, which has been discussed a lot, has been getting a lot of attention in the graph drawing community and data visualization. It's about rerouting the lines connecting the locations or graph nodes so that they form bundles. And we kind of see those highways where there is more movement on the map. But it has the same issue that we kind of lose the information on where are their origins and destinations. Like within a bundle, many flows from different origins are bundled together, and when there's an exiting line, we don't really know what its origins are. There are not many user studies about flow maps, but this one is good. Here they did a user study with about 200 participants, and they looked at a few techniques for flow map rendering, and they found that using curved lines is better than straight lines. Using arrowheads is better than tapered lines, and connecting flows between the nodes, drawing the lines connecting the nodes, centroids of the areas considered, is better than drawing them between the borders of the areas. Here, like the percentage you see is the number of correct answers they got in the study, and here it's much higher. They also, in this paper, they summarize the past work and advice from other papers, so it's a good read. Although many of the techniques are difficult to implement in an automated solution, especially with many flows. Yes, a few examples. There is a good collection maintained by R.J. Andrews, the author of the book Info We Trust. It's a Google presentation with many flow maps. There are a few other examples which are actually not on that collection, which I found interesting and wanted to show. This one actually uses a map distortion to emphasize the areas where there are more dense locations, distributions of locations, right? For instance, here we have Europe, and we see inside Europe there are that many locations. Africa is underrepresented because it's not well connected to the global internet map. Therefore, it's very small here. So it's a useful technique in this case. And here at the bottom, you see how it would look like how proper flow map, geographic flow map without distortion would look like. Here we have much less space for the dense areas. This one comes from Switzerland. It was published as part of the Atlas der Schweiz, Swiss atlas, made by Eduard Imhoff in 1967. And it shows commuters in Switzerland. And it's interesting because it puts a lot of attention to the totals for the locations. We see quite well like the color coding, red stands for locations where there are many incoming flows, and blue for where there are many outgoing flows. And by using these interesting glyphs, we see the totals for the locations. And this one is interesting because it uses the third dimension to connect the origins, destinations, and also time. This shows the tourists' paths in New Zealand on the first week, and these are the origins. Here is where most of the tourists start, and they go to this place on the first day, and most go to this place on the second day, and so on. That's quite an interesting flow map. But as I mentioned, flow maps have issues. There are alternative ways of representing OD data. I won't discuss them in much detail. If you want to, I put a link to my thesis where I discuss them. But I just want to say that they all compromise something that flow maps have, mostly the geographic representation and the spatial overview. But they reduce the cluttering, or they treat all the flows independent of their distance equally. That's why they solve the problems, the issues which the flow maps have, but they are we are sacrificing something which flow maps have, the geographic representation, or or it takes some time to learn how to read it. Like OD map is extremely powerful, but it takes people some time to learn how to read. So I thought that we can do something about the normal flow maps so that they are more usable, and try to solve the problems which they have, but still making a representation which is easy to understand for most people. So I've been on the quest of developing a flow mapping tool, and I wanted to make it easy to use so that the entry barrier is low. It should work on the web so that it's easy for people to share. It should work for various datasets, and it should be pragmatic. It should focus on one thing, do it well, and that'll also save me the development effort. And I couldn't have implemented it without the technology which we currently have. WebGL is rendering, actually is a technology for 3D rendering in the browser. And the flow maps don't really require 3D, but that's the technology which is the most performant for graphics on in the browser. It's difficult to use, but we can draw many objects with it. Mapbox is a fantastic WebGL mapping technology, which I'm using for the base maps. DeckGL is a tool for creating WebGL overlays for a map. It makes it much simpler, much easier to render something with WebGL, and it's made specifically for mapping, for geographic maps. And maybe like it's really an enabler for Flowmap.blue. Google Sheets, it's a data backend. I don't have to think, like Flowmap.blue doesn't have any backend. It doesn't have any database where it stores the data. Data is loaded directly from Google Sheets. I don't have to, it saved me a lot of effort implementing it. And Google Sheets, there is this Google Charts API, which allows to fetch data from a Google Sheet, which is really easy to use. You need to specify a URL, pass the ID of your spreadsheet in it, and then you can get the data. You can even run SQL queries on it to group or filter the data, but it's not necessary. So Flowmap.blue, this is how it looked at the beginning, the website. This is how it looks now. And what can it do? Like people can upload their data to Google Spreadsheet and visualize it as a flow map. There are a couple of steps you need to follow. There is this template spreadsheet which people need to make a copy of. And it has 3 sheets. Properties where the metadata lives. You can set the title, description, the source, set some settings. There's a location sheet where you just list the locations which are used in your flow map. They have IDs, and then we can put the flows in the flow sheet. And here we have the origin ID, destination ID, and count the magnitude of the flow. Then you have to share the spreadsheet so that Flowmap.blue can get data from it. And then you paste the URL to this form, and you get the link to the spreadsheet, which is persistent. So you can share it, you can send it to somebody, and they will see the same flow map. And if you open this link, you will see a flow map. Yeah, and so far it's been a success. Quite many people have been uploading data and visualizing it with Flowmap.blue. Very, very different data sets. I put those which are public to the website. There's a gallery, and there are data sets from showing very different phenomena. Many are showing commuters. There are also migration data, bus, air travels, train travels, bicycle sharing systems. But there's also bird migrations data, supply chain, historical journeys, scientific collaborations. Very different phenomena can be described in this simple model. So I want to speak a little bit about the visual design decisions I made for Flowmap.blue. First, I decided to use straight lines to represent the flows. Honestly, it's because, for the most part, it's because they are easier to implement. Also, they are more performant. In WebGL, you need only 3 triangles to draw an arrow, and if it was if it's a straight arrow, if it was a curved arrow, you would need hundreds of triangles, which would make the performance much worse. But also, I think that for larger datasets with many flows, it might be that the straight lines more fit better, because they actually use less space, so they produce less overplotting. And also they're kind of more predictive. When you look at them, it's easier to see where they're going compared to curved lines. But that's just my hypothesis. In the study, which I cited before, they actually made the experiments with flow maps which had very few, like a few dozens of arrows, which might be different, I think, with datasets with many arrows. Then very important is that the arrows are sorted. Sorry, the largest are at the top, so they get the most attention. I draw outlines for the arrows, because otherwise it would be like one blob of color when they would be overlapping. And to show the magnitude, I use double coding with the thicknesses of the arrows plus the color fading. There's no transparency to avoid color accumulation. It's just the color is really getting darker. But still, like we have a lot of overplotting. It's with the sorting and the color fading, it's kind of okay to read. But many lines are crossing. And still the smaller flows are less salient. Like here we have quite a big flow, which is very short and very difficult to see. So this problem is not solved here yet. So for fading, actually, I decided to add a slider in the UI. And the users can adjust the level. Because depending on the dataset or what part of the dataset you're looking at, you want to see more, you want to have more or less fading. You see only the largest flows or all of them. Also, it's important that the base map is visible at all times, even if you have many crossing lines drawn over it. So we use I use a blending technique so that the colors of the base map are blended together with the colors of the arrow, so the map is still readable. And then I find it very important to show some summary for the locations. So we show I show here with the circle sizes the total number of flows for each location, because without it, it's very difficult to say which location has more. You cannot just easily. It's not that easy to sum up the arrows just visually. And actually, in Flowmap.blue, there is I show at the same time the outgoing and incoming flows so that you can see the difference. Here you see commuting the data for morning commuters in Seoul. And for instance, here, this is probably the office area, the main office area in Seoul, where there are mostly incoming flows. I try to use this metaphor of getting fuller or getting emptier. So if there are more outgoing, then it's getting emptier. Whereas other areas are probably the sleeping areas where most people live. And so with this representation, it's easy to see which locations have more incoming, which have more outgoing. There is also an animation toggle in the tool. Just beside being fancy, it actually can be a useful alternative for showing the flow direction. Sometimes it's more readable. And it also generates a certain emotional response. You see like this recurring flows of people, and it works nice with the commuters, right? Because they go to Zurich every day. But you should be careful with it because, for instance, if you use it for refugees, it can generate an emotional response you don't really want, like we are invaded. Yeah, but that's an option in Flowmap.blue. Some datasets look messy, like I saw what people were uploading. For instance, these are bus travels in Sao Paulo. Like actually depending on the mode of transport, datasets can look messier or less messy. Like there is this first law of geography, which says that closer places are more connected to each other than farther away places. But it actually doesn't hold, like it usually holds in general if you look at all the trips, because more trips are done by foot to closer by areas. But if you change if you filter only one mode of transport, it may actually differ. For instance, here bus travels are usually made for longer trips. It looks the same for air travel, for instance. But the problem with that is that there is more overlap. We have more arrows which go farther, and we have more overlap. And this representation, this map is not super useful because there is so much overlap, right? We have a lot of overplotting. This is another example showing relocations in Australia. And Australia is sparsely populated, but there are many areas which are very densely populated. And actually, this is where the largest arrows are, right? So we actually, the largest areas are not visible here at all because they go between the close by locations. So that's actually the same problem I mentioned before, that the short flows are not represented because because locations are so close to each other. But can we somehow solve this by producing a useful summary? I tried implementing clustering for that. So how does it work? We have the locations, right? And we start with the largest and form clusters around them. So smaller locations around the largest locations within a certain radius gets clustered with the largest ones. And then we sum all of the flows between the locations within the clusters so that we get aggregated flows between the clustered locations. So this way we have the clustered locations placed in the center of masses for each location within the cluster. And we have the aggregated flows between them. And for the two examples I showed before, this actually improves the readability a lot. Right, so we have now the clustered locations and flows between the clusters. We have a lot fewer flows to draw, much less overflow, and we don't have short flows anymore because the locations which were close together were clustered together. But we kind of lost the detail in this process, right? We don't anymore see flows between the individual locations, which we had in our original data set. We can solve this by adaptive clustering. This clustering approach, which I use the library supercluster, is very fast, and we can apply it on the fly, adaptively, depending on the zoom level. And so when we zoom in, the clusters expand. When we zoom out, they cluster together. But when we zoom into a smaller region, right, we have to expand all of the clusters. And that means that we will have still too many flows to draw, most of which will actually be outside of the viewport. Or for many of them, like you see here, we have many flows which have their origin and destination outside of the viewport. It's not useful here, right? It's just noise. Besides, it makes the performance suffer. And it's useless most of the time because we don't even see the locations. They are not in the viewport. So can we remove them? This is what I'm doing in Flowmap.blue. I filter the viewport, the flows by the viewport, only keeping the flows which either start or end in the viewport. And at any time, there are not more than 5K flows shown in the viewport. This is a magic number I came up with. It's big enough to show much of the detail, and it's also small enough to guarantee that the performance is okay. And also the scales are adjusted, so the thickness of the arrows and the colors are adjusted so that we can see the detail. Here's how it works. You see, when I'm zooming in, more arrows appear. When I'm zooming out, some arrows disappear. And also the scales adjust so that the largest arrow in the viewport gets the full width. So the adaptive filtering helps to ensure good performance, remove noise and clutter, and we can explore the small regions in detail. The two techniques together, we can see how it works in this example, showing the routes, airplane routes across the world, as it was in 2014. So you see, as I'm zooming in, I see much more detail, and also the scales adapt so that I get the full range to compare the arrows within the view. And also the performance is okay, even if there are quite many arrows in the whole data set, but they get filtered and aggregated as we navigated the map, so that we don't have to draw too many of them at a time. So yes, as I mentioned, these are the two main Flowmap problems: overplotting and short flows not getting enough attention. And like these two techniques are kind of solving it. It requires interaction, right? But still the datasets can be explored. So the overplotting, thanks to the adaptive clustering and filtering, is not that much of a problem, because by clustering and filtering, we reduce the number of arrows to draw to only the important ones, and there is much less overlap and overplotting. And the short flows being not visible or being less salient is also solved by the clustering and showing location totals. Because if two locations are close to each other, so that they get clustered together, right? So therefore, there are no flows which are too short in the view, unless we zoom in. But when we zoom in, we see the more detail, and the flows become longer so that we can see them. But when they get clustered into a cluster, we see by the location totals, we see that there is some movement inside this cluster, right? So we know, okay, we can zoom in and see more detail for this cluster. So this is the dataset showing commuters in Switzerland. So this was without clustering, with this issue with the short flows being not visible. But when we cluster, we don't have this problem. And we can still zoom in to see the detail. So I wanted to share a few use cases, interesting use cases, which were somewhat unexpected. This is a dataset uploaded by Peter Koim, showing the sewer system in King County, in the state of Washington. I didn't think that sewer system is also about geographic movement, but it appears to be the case. Also, people started to use Flowmap.blue in unexpected ways. For instance, by producing traces of movement. Like here's somebody created a historical trace of a historical journey by just specifying the origins and destinations of the trace in as OD data. And I totally didn't plan for that, but somebody used Flowmap.blue to represent vector field movement as a vector field by just specifying like a grid of locations and then connecting them with flows as origins and destinations. And this is bird migration model made by Raphael Nussbaumer. Quite a number of data sets about coronavirus have been uploaded. This one was one of the few public ones, showing how the virus spread across the globe. It's published on this website, endcoronavirus.org. There was a TV appearance, like an investigative journalist. There was a program on a German TV with a story about the spread of the virus in one of the originating in one of the Austrian ski resorts. And I have at least one happy customer. The tool is free and open source at the moment, but Philipp Walter, working at a bike sharing program in Kiel, Germany, has tried to use it, and he's very excited because previously he just looked at the data in Excel. And I continue to work on the tool. There is no end in sight. I have many ideas on how it can be improved. Recently, I added timeline functionality. Now the data can be filtered by time. And here you see bike sharing data from Montreal, and then it can be filtered by time. So we are almost at the very end. Summarize. Flow maps represent interactions between locations. So they are showing locations, interactions between pairs of locations. There are many real-world phenomena which can be described in this model. And flow maps are inherently geographic. That's why they are a good representation of the spatial situation, right? You see well the relative locations, the relative positions of the areas, and you see how far the flows go. There are issues with them, but they can be addressed with certain visual and interactive techniques. And they can be scaled, meaning they, like, even larger data sets can be represented with adaptive filtering and summarization. For example, clustering. Flow maps used to be difficult to produce, but I'm doing my best to try to change that. So that's why I developed this tool. And here's something I learned while working on the tool. I'm doing it in small steps. That's the only way it really can advance. And that's the statistics of my Git commits on this project across the past year. It's good to publish early and often to get feedback and to see how the tool is used and to adjust accordingly. It's good to limit focus, not try to satisfy every possible use case, but try to make decisions on what to focus. Also cut corners and use the easiest approach first, then to get some feedback, improve and update. And I really benefited from the available technology without which it wouldn't be possible, like libraries and tools like Mapbox, DeckJail, and Google Sheets. And I'm also trying new things like clustering. I saw the problem with the datasets people uploaded. I tried it and it worked. And it doesn't have to be perfect. If it's solving a problem, even if it's has some corner cases or some issues, it's good to share with the people so that they can use it. Yes, this is showing again the global airplane routes. And this is to illustrate that we live in a very connected world. And it's important, I think, to understand these connections. And to understand these connections, because they are quite complex, we need good tools. And tools can enable people in what they do. So that's it, what I wanted to share. If you have questions, I'm happy to answer.
Thank you very much, Ilya. It was really extremely interesting. I personally noted down many ideas of OD data that I will want to visualize with your tool.
Cool.
So we do have some questions. So I suggest I will go through them and let you answer. So the first question that we have is how did the unexpected use of your tool influenced the further development of it?
That's a good one. Specifically for instance, for the bird migration as a vector map, vector field. I actually added an option to hide the location totals because they were not useful here. Once I saw this dataset was uploaded, I added this option. That's an example of how it, because I thought maybe other people would also try to do that. And somebody actually did. Somebody tried to upload a dataset showing the movement of a glacier also as a vector field. But I probably wouldn't. It's pretty cool that the tool allows this, but I still don't consider it the main use case, at least at the moment.
Thank you.
Also for this one, for the Seattle sewer, like the original dataset which Peter uploaded was really big, and I saw that there were performance issues when I tried to zoom in and out. That was one of the triggers, one of the reasons why I implemented the adaptive filtering and clustering. So,
so we have like another question. Is it possible to filter the arrows on the count value? So their thickness.
Not at the moment. What you can do is change the fading.
Is it something you want to develop further?
I'm not sure. Like you can change the fading, and that effectively removes the smaller flows from the view, right? But you cannot just set a threshold to filter the flows. That would, yeah. So not at the moment. That's the answer, but I will think about it.
Thank you. We have another question. I'm taking the questions in the order of the votes. So if you want to upvote questions, please do so. And so the question, do you think that there could also be a use case which do not rely on geospatial locations, but actually rather abstract connection data?
Definitely. But that's a little bit of a different use case. Like that would also imply that we can actually move the nodes, right? Probably. And this is kind of adding another degree of freedom to the visualization, which is not necessarily good. I mean, it's not necessarily making it easier. So in Flowmap.blue, I really try to focus on geographic data. But maybe, I thought of maybe making the layout, adding an option to switch the layout to a certain graph layout, forgetting about the geography. So we could look at the data in a non-geographic representation with a proper graph layout, which would reduce the problem of the short flows, for instance. Then if I go that way, then probably it would also make sense to add support for non-geographic data up front. But I'm not sure. Yeah. For now, I focus on geographic data.
You kind of tackled the question a little bit in your presentation when you showed like other representation of OD metrics, like arc diagrams or chords or things like that, I think.
There also, yeah, completely non-geographic and non-graph alternatives. Yeah.
Thank you very much. Another question. Can I use a custom base map with Flowmap.blue?
Yes. There is an option like you if you open the template spreadsheet, there is a property, where is it? Mapbox map style. So you can paste here a URL of a Mapbox style. Mapbox has this fantastic studio for designing your own map styles, and you can do many things. You can also upload your data on it. Like here, for instance, I uploaded some shapes here. Then I can share the URL. You copy the style URL, you paste it here, and then it will appear in Flowmap.blue. Here there are actually a couple of examples. For instance, here, this one actually uses the map shapes from Swiss Topo, right? They have an experimental API for vector tiles. You see this URL, it's from geoadmin.ch. And it supports Mapbox style format. That's why you can just paste it here, and it works with Swiss Topo tiles. And this one shows some background data. So in Mapbox Studio, you can upload a dataset and visualize it somehow. And yeah, it's shown here in the background map under the flows. So I didn't have to do much for that. Benefited from the great tools.
Thank you very much. The next question that we have, what are some of the other ideas and features that you're most excited to be adding in the future?
Oh, thanks for the question. So there are currently limits to how much data can be loaded into the app. On one side, it's because of the limits of the Google Sheets. The largest data set I've had so far is 1 million rows. You really cannot put more in Google Sheet, in Google Spreadsheet, but that's already quite good. But as soon as you add, for instance, temporal dimension, like here, the number of rows in your data set grows very quickly. So I'm thinking of adding a backend solution with a proper database. I'm looking at BigQuery, which handles really well large tables and is good with aggregation. So when I enable people to upload data to BigQuery and then connect with Flowmap.blue, this would work for much larger data sets, but I wouldn't be able to do it for free. So I'm thinking of maybe creating a commercial version of Flowmap.blue where people can upload very large data set, or for those people who have very strict rules on how private the data should be. Because currently for Flowmap.blue, you have to share your spreadsheet so that anyone with the link can view. It's kind of effectively private as long as you don't share the link, but I think many companies will not be comfortable with that. And yeah, so enabling larger data set with a database, and also adding some attribute support so that you could filter the flows by some attributes like mode of transport or whatever is in the dataset.
Cool, thank you very much. We have a few more questions, but I also see that it's already 6 p.m. So I think maybe we can, if you are available, maybe we can go a little bit over the limit, just to wrap up maybe the session before. I would like to say, first of all, thank you very much, Ilya. It was really very interesting.
Thank you for the opportunity and for organizing.
Like a bit of meta information. We would really like to have all your feedback about how you think the webinar went. I can already see in the chat that there are a lot of good feedback, so thank you very much. And mostly good feedback for you, Ilya. So thank you very much for that. Don't hesitate to reach out to me or Benjamin for feedback, either on meetup.com, on our meetup group page. And we also now have a Twitter account, DataViz ZRH, DataViz Zürich. So don't hesitate to reach out using Twitter also. We will monitor the account. Also, if you have ideas for potential topics or potential speakers for the future. And yes, and we have the next meetup planned. It will happen June 10th at 5 p.m. Also a webinar, and it will be about data visualizations in video games. And we will welcome Yannick Rocha, who is a researcher at EPFL in Lausanne. So we are really pretty excited about this too. So yeah, that's it, I think, for the closing statement. So I don't know, Ilya, maybe if you have a few more minutes to answer further questions, if it's.
Yes, I do, sure.
Okay. Okay, then I will go through them a little bit. For showing the two opposite directions of flow between two locations, have you considered other design solutions than your nice split arrows?
Actually, one of them is the animation. I'll show. So here, actually, it's a bit subtle, but I kind of like it. If you see, for the arrows going in opposite direction here, they are actually going. They actually overlap, but you can still see. So they take less space than if we put them next to each other. But you can still see both directions because they are half transparent. But also, yeah, there are many different approaches which would be possible. I kind of like these half-barbed arrows most from all I have tried. That's why I keep using them. But maybe I'll add an option to Flowmap.blue to show curved arrows. And there are some approaches. I think I even had it somewhere. Like you can use the curviness of the arrow to show the direction. And yes, there was yes. Also, you can use tapered arrows, but there was some in this paper user study which I showed before. It proved less effective than arrows. But in part, it's because it's easy to implement, and they also take less space on the screen than some of the other options. That's why I'm using it now.
Thank you very much. Yeah, actually, I see that I thought we were almost done with the list of questions, but I see there are like quite a bit more. So I don't know what you think, Ilya, but maybe we can propose to that participants who have more questions can maybe reach out to you directly, maybe on Twitter. And so maybe we can wrap the session for tonight.
Sure. Like
Okay.
my Twitter is Ilya Bo. You can write me. I'll be happy to answer your questions.
Okay.
Or I can can I answer the questions here in the chat? I can comment. Maybe I'll do that. Yeah.
Yes, you can absolutely comment on the questions and answers.
Let's answer this question which got 2 votes. Okay with you? And then we will.
Okay. Okay, so as far as I understand, Flowmap has been developed as a part of a commercial tool first. How did you and Teralytics come up to a decision to open source it?
No, that's not quite the case. So at Teralytics, so the first Teralytics, we open sourced. So we first developed this DeckGL layer for rendering flow maps. And this is what we are using in our commercial product. But we open source it as a library. So you can use it, but you need to write some JavaScript code for it, right? And Flowmap.blue, I developed in my free time outside of Teralytics. And Flowmap.blue also uses this library, which we open sourced at Teralytics. So Flowmap.blue is a separate thing, but it uses this library, which we published. But for Teralytics, they supported me because at first we have, at least so far, have been making more money selling the data and not the tools. And also this open source tools and libraries bring some more attention to Teralytics, so it works to some extent as marketing tool. That's why they supported me in open sourcing it.
Thank you.
Okay, let's wrap up.
Sounds good. Then thank you again really very much, Ilya. And
thank you again for organizing.
And thank you everyone for participating to this event and for being so active in the chat. It's very nice. And we will see you all again for the next webinar, and hopefully in real life soon also. Bye-bye.
Bye, everyone. Thanks for your attention.